Okay, this is our Day 19 Solutions. It's a review for the quiz. We're going to be graphing exponential functions here. The base is this number e. It's just a number, 2.718. The 2 out front, that's going to be your a. That's going to give me a vertical stretch by a factor of 2. B is a number in front of x. That's going to be 1. That's none. So I've got h as a -1. That's going to go left. And k is equal to a -2, which is going to go down. All right. So if this was a 2, a 3, it's just a number. It's just the base. It does affect it, but the general shape of an exponential function won't change. It comes up. It has 2 key features that we're going to graph here. We've got the point 0, 1. And we have the horizontal asymptote, y is equal to 0. So those are the 2 things that I'm going to go ahead and graph. First thing I'm going to graph is the asymptote, because there's only one thing that affects the horizontal asymptote, and that's right here. It's going to go down 2 units. Nothing else can affect it, so y is equal to -2. Now the only other thing I have to do is figure out where that point 0, 1 has moved to. I'm just going to run it through these 4 transformations. A, no matter what A is, it always gets multiplied by y. So I'm going to times this guy by 2, and that gives me 0, 2. That's my vertical stretch. B is 1, so it does nothing. I multiply x by 1 for B. It always gets multiplied by x. The -1 gets added to x, so h always gets added or subtracted, in this case, to x. So that gives me -1, 2. And for the same thing with k, except I'm going to add it to the y. K's always get added to the y's. And that's going to give me the point -1, 0. And that's all there is to it. So that's just going to come along here and then shoot right up. Domain will always be set of x's such that x is an element of all real numbers. And the range is always going to be from the asymptote up, or if it was a reflection over the y-axis, it would be from -infinity up to that -2. That's all there is to it. All right, 1b is another graph here. So the 2 is my base. Kind of tricky here. A is not -2. A is -1. That -1 is not being raised to the x minus 3. Just the 2 is. You would have to put parentheses around it like this if we wanted it to be the base of -2. So it's a little bit different. A being -1 is going to be a reflection. It's going to reflect over the y-axis because A's affect y's. B, in this case, is 1 right in front of the x here. That does nothing. H is going to be a +3. That's going to move me right 3 units. And k is equal to 1, so that's going to go up. All right, so first thing we move, as always, is going to be that horizontal asymptote, which is simply your y value, so y is equal to 1. I'm going to take the point 0, 1 and transform it. Well, it's a reflection, so that's going to reflect over the y, so I'm going to multiply my y value by -1. 0, -1. That just reflected it from here down to here, because my graph is going to go down like this. Don't do anything with b. Move to the right 3 units. I'm going to add 3 to x. That's going to give me 3, -1. And I'm going to go up 1 unit, so I'm going to add 1 to the y value here, giving me my final resting place of 3, 0. So I go over here 1, 2, 3 units, and that's going to be 3, 0. So my graph is going to come along the horizontal asymptote and now go down because it is a reflection. Domains never change. It's always going to be such that x is an element of all real numbers. And now because it's a reflection, we go from, for the range, we go from negative infinity up to the horizontal asymptote. Okay, for the rest of these word problems, I'm not going to write them down. I'm not going to read through the whole thing. You have them in front of you. I'm going to go through them fairly quickly. The first one is an annual interest rate. There's nothing about compounding, so I could use the formula A equals P times 1 plus R raised to the T. Or if you put in divided by N and times N here, since it doesn't say anything about compounding, the number of compoundings is 1. All right, so A is what we're looking for. P or A sub 0, doesn't matter which one you use, is equal to your beginning amount, that's $100. And the rate was given as 4%, 0.04. And I believe they asked us to do this for 12 years. So I'm just going to substitute in 100, 1 plus 0.04, and that's raised to the 12. And I'm just going to go ahead and give you the final answer, because I think at this point, if you're messing anything up or having trouble, it's getting this written down correctly. Okay, number 2 isn't dealing with money. It's dealing with cell phone subscribers. So the only formula that I can use is A is equal to A sub 0 times 1 plus R to the T power. I can't use any other formula because you can't compound people or subscribers of cell phones. So I've got my ending amount, don't know what that is. I got my beginning amount. I believe there were 285 to begin with. And the rate is given to us as 75%. So it increases 75% per year. And we're going from 1985 to 1994. So that's going to be a difference of 9 years. So my time is 9 years. So we're going to go with 285 times 1 plus 0.75 raised to the 9. And if you do that correctly with your calculator, you get 43,871. Okay, number 4, we're dealing with bacteria. So again, it's not money. The only formula I can use with bacteria, people, subscribers, A equals A sub 0, 1 plus R to the T. The only hard part is here, what is the rate? I know I'm looking for the ending amount. I know the beginning amount. What do they tell me here for the beginning amount? Well, it doesn't. So this one's kind of really weird to begin with. So a little trick. I'm not sure if I did one like this for you or not, but let's see what we can come up with here. The beginning amount, you can just say is 1, representing 100%. So if they don't give you an amount that you begin with, you start with 100%. Oh, I'm sorry, it does give me here. It says 1 bacteria. So we do start with 1 bacteria. But if it didn't say it, you can also put 1 in there, just representing 100%. And then your answer is not going to be a total number. It's going to be a percentage increase. All right, now it doubles every hour. So if I'm doubling, that is also a 100% increase. So that's going to equal 1 here on this end too. And we want to know at the end of the day, so we're going to go ahead and 24 hours because it doubles every hour. So my beginning amount is 1. This 1 plus the rate, the doubling is 100% or 1. And I'm going to raise that to the 24 power. So it's going to be 1 times 2 to the 24, or that's 16,777,216. So there's the power of exponential growth. All right, 5, we're dealing with a tennis tournament. We start with 120 players. So what we start with It's 128 players. During each round, half of the players are eliminated. So the rate, if we're eliminating them, we're going to go minus 50%, or that's going to be a negative 0.5. So my formula here, A is equal to A sub 0 times 1 plus R. In this case, it's minus R raised to the T because we're dealing with this reduction. And I believe they're going to play 5 rounds, and we want to know how many people are left. 128 times 1 minus 0.5 raised to the 5th power. And you're down at 4 people. Okay, number 6. We got a breathing problem. You got about 12% of the air in your lungs is replaced after 1 breath. We want an exponential decay model for the amount of the original air left in your lungs if the initial amount of air is 500 milliliters. And then how much is present after 240 breaths. It's the same exact problem as this, just different numbers. We've got to figure out what my A is, what my A sub 0 is, what my rate is, and how many times we're breathing. All right, well, obviously this one we don't know. The beginning amount, 500 milliliters. And it says we reduce about 12% of the air is replaced. So that means I'm subtracting out 12% of the original air that was in there. It's getting replaced with new air. And then we want to know after 240 breaths. So A is equal to A sub 0, 240. No. Oops. Come on. 500 milliliters of air left. 1 minus a 0.12. And that's going to be T. That was the first question. What's the model? But we're looking for it after 240 breaths. Don't know what just happened to my pen there, but we're going to raise this to the 240 power. So after 240 breaths, 246, 240. And it's going to be a very small amount. Your calculator is going to give it to you as 2.37, and the way the scientific calculators give it to you is E, and then negative 11. If you remember, that's going to be 2.37 times 10 to the negative 11th power, which means I've got to move my decimal 11 places. So there's going to be 10 zeros here. And that's a very small number. That's the amount of the 500 milliliters. The amount of that's left is 0.00010 milliliters of the original air left in your lungs. Okay, number 8 is another reduction. So we're taking ibuprofen, and each hour the amount of ibuprofen in your system is decreased by 29%. So again, we're just dealing with this A equals A sub 0, 1 plus R raised to the T. Always make these problems as easy as possible. Just list what you got over here and then substitute into your equation. All right, so we take 400 milligrams of ibuprofen. It's going to reduce at a rate of 0.29, 29%. And we want to know after 6 hours, how much is left? Well, we're going to take 400, 1 minus 0.29, raised to the 6th power. And that's going to be 51.24 milligrams left. All right, number 9, we're back to a money problem. So it's going to have 2 parts to it. Both are going to start with the same amount and the same time. It's just different interest rates. So the first one, it says compounded monthly. So A is equal to, you could use A sub 0 principle, 1 plus R over N raised to the NT. So A is equal to something. The beginning amount is $1,600 is what we start with. The rate here is going to be 2.5%, or 0.025. Got to be careful, get that zero in there. And I'm going to keep the money in there for how long? Looks like 3 years. So time is 3. And this problem has n, compoundings. So it's going to be compounded monthly. So there's 12 months in a year. So we're going to have a 12 there. So we're going to go with 1,600, not 160. 1 plus that 0.025, and divide that by 12, and I'm going to raise it to the 12 times 3. And if you do that properly in your calculator, you should get $1,686.05. All right, so we're going to do the same, but we're going to compound continuously. So A is equal to the principal times e to the RT. So we're looking for the ending amount. Our beginning amount didn't change. We're still dealing with it, $1,600. The rate, I believe, does change here. Yes, there's going to say 4% annually, so 0.04. The time is still going to be 3 years, and we don't have any n because it's compounded continuously. That's why we're using our e. So that's going to be 1,600 e to the rate 0.04 times time of 3. And that's going to be $1,803.99. All right, well, I hope that helps you. We got the quiz tomorrow. If you have any other easy questions, please feel free to ask me on Google.